Hello, this is a video for EDX Statistics 1. It is the first video in this series and it will look at calculating the mean and variance of a set of data and also the theory behind them. The mean, mode and median are all measures of location or centrality. The arithmetic mean is defined like this, and because every data item contributes to it, it can be influenced by unusually high or low values. If you're working with frequencies, then you use this formula instead, and each x value occurs with this frequency. Here is an example of calculating from a frequency table. So here we have thrown a dice 120 times and recorded the scores. So here the number 1 has been thrown 22 times, the number 2 18 times, and so on. The first thing we need to do is multiply these two numbers together. And this gives us the following numbers: the frequency times x. And we've also added up both of those two values to give us sigma fx and also sigma f. Calculating the mean then gives us 3.42. To consider variation and standard deviation and variance, we'll think about a small set of data to begin with, just these 5 points of data, the mean of which is 2. If we want to consider how spread out this is, the deviation, that is, from the mean, we could subtract the mean from each of these values to give us this. These deviations give us an idea about the spread of the data. If we just added these up, however, we would just get 0. So rather than do that, we're going to square each of these values and then add them up. And that will be considered the sum of the squares, and it's denoted SXX. In this case, this works out to be 16. To turn this into standard deviation, we begin with the sum of squares, and we want to divide this by how many pieces of data we've got, in this case 5. So we divide 16 by 5 and we're going to get 3.2. And this is the standard deviation squared, or the variance, sometimes known as the mean squared deviation. To get the standard deviation, we then square root this answer, and this is called the root mean squared deviation, in this case 1.789. So here's the general formula for standard deviation: the sum of x minus x bar squared over n, all square rooted. There are other formulas, however, that we can use for finding SXX, and these two are the most common. The lower one is generally the one that you'll see because it prevents any rounding errors with the mean here. If we want to find the standard deviation, there are actually two different types of standard deviation. The one on the left is more commonly known as the root mean square deviation, and it's found by dividing SXX by n and taking the square root. But in some circumstances we want to divide by n minus 1 instead. And the reason we do this is because the variance, in this instance, is considered the unbiased estimator for the population. Interestingly, however, you cannot just assume that calculating the S as the standard deviation is a good unbiased estimator for the population standard deviation sigma, as it tends to underestimate the population standard deviation. So to look at the difference between these two calculations, here's the first example. Consider that we have a population made entirely of 6 different numbers, just these 6, 1, 3, 4, 6, 8 and 9. We want to find the population variance, so in other words, the variance of every single number in the population. So we can use that formula from before, SXX over n, to give us 7.81 to 3 significant figures, and then square root that to give us the standard deviation. Now you can get this number straight out of your calculator, and it's worth spending some time with your calculator as all of them are different in order to be able to find this from your calculator. If, however, we didn't have the whole population, so in this case we're only going to say that we had, say, 3 numbers out of this population, and we want to find an estimate of the overall population variance and population standard deviation, we have here a small sample, 3, 4 and 8 from our population of 6. Okay, so we just have these 3, and we can calculate s squared, which is the same thing as before, the sxx, but this time over n minus 1, and this works out to be 7 in this instance. So in summary, when sampling, dividing sxx by n minus 1 gives a better estimate of population variance than dividing by n. We want the expected, so in other words, if we did this a lot, the average value of the measure spread to be equal to the population variance sigma squared. And it turns out that the value of s squared for sample size of n is exactly sigma squared for the whole population. So dividing by n for the variance of the sample would on average give an estimate of sigma squared that was too small. That's the end of this video. The next video in this series is looking at the binomial distribution.